In this video, we're now looking into analog control. So previously, and for most of the tasks that we've done so far, it's been pretty much digital. We've been controlling digital devices and we've been using digital signals, inputs and outputs, okay? Digital is just on or off, whereas really some of the more interesting stuff is analog, okay? It's something that has a range, and if we just think about pressure, we could have a little bit of pressure, a little bit more pressure, a lot of pressure, a lot more pressure, okay? So there's a range of values, it's not just on or off. So what we've started to do in our discussion for digital signals, we've tried to keep it really simple, just to start out with. And this is what I've got here, okay? I've got our potentiometer, which is going to act as our analog input. I've got an LED, and of course we've got our MBED there, okay? Now the key thing with our analog input, our potentiometer, is we've got a power supply to it, we've got a ground wire, and then that yellow wire is our analog feed from the potentiometer, okay? So we're taking along there at 3.3 volts, and then we are essentially grounding it, we're getting the common ground, and we're using, as I said, 3.3 volts. So what a potentiometer does is it just changes the resistance value. As you turn this dial, it will change the value of the resistance from a maximum to a minimum value. So we know our formula, Ohm's law, voltage equals I by R, current by resistance. So as we change the resistance, it's going to change the voltage that's going in on pin 15 at the moment, which is one of our analog input pins. So we know our analog inputs are pin 15 down to pin 20. There's 5 of them. So it's given us a varying voltage, which is ultimately an analog input because it's just changing. It's not just an on-off signal. It could be given a little bit of voltage in, a lot more. And what the microcontroller is going to read that, and then it's going to scale that back out to the output. So it's going to give a proportional output to the output, so that it'll basically dim or brighten the LED. So what we're just going to do is we're going to see this in action. Just cover my hand over it just so that we can see it a little bit better. And hopefully you can see the LED brightening and the LED dimming, because the microcontroller is reading the analog input. It's seeing that we're getting a range of values in, and then it's given a range of output out on that particular port. Now it's important that we connect it to pin 18 because that is the only analog output pin we have. Okay, we've 5 analog input pins like we said, but we've only 1 analog output. Now just to show you, I've hooked up a multimeter here, and it's a little bit hard to see, so apologies, but I'm just checking the voltage that's going in on this yellow pin here. It's a bit hard to see, but that's where I'm checking it, in on that yellow line there, which is the analog value that's coming out of our potentiometer, okay? And you can see, just as I'm changing this potentiometer, the voltage is changing from 0, which is ground, all the way up to 3.3 volts, which is the voltage that I'm supplying it with, okay? And then we can still see the LED changing appropriately, okay? Now just one thing to note, that's the input. That doesn't necessarily mean if we were given in, 1.2 volts, that it's going to give out 1.2 volts. That's not what we're saying. We're just giving in a range of values in here, and then within our code, we're deciding how much then to give out, okay? So there's not a direct relationship there, just so you know. But this is only the start of our analog control, okay? The main thing you want to keep in mind is that we have an analog input because it's a changing value of voltage, and really we're just manually changing this. If we had like a temperature sensor or a pressure sensor, like I said, it would be automatically changing its value based on, the event, the circumstances. But here we're just manually simulating an analog input. and then our code is looking to either brighten or dim the output. Okay, so hopefully that makes some sense. And what we'll just do here is we'll have a quick look at the wiring diagram, which shouldn't be too bad. Simple potentiometer is just three legs on it. One of the legs has to go to your power supply, the other one has to go to ground, and the middle one goes as your analog input. Very important that your analog output, it's the only one, if you look at the MBED card, it's the only one on pin 18, so it has to be there. Then we have our common ground for our LED. So the wiring diagram shouldn't be too bad, same with the schematic. And then into our code, like I said, we're going to spend more time looking at some analog stuff. But what we've done is we've just declared an analog in and an analog out. Very important, this is the only analog output pin we have. We have 5 of these analog input pins. I'm telling you, there's a 12-bit analog to digital converter, because we're taking in an analog signal and then we're converting it to a digital signal inside the MBED. And then we have a 10-bit digital to analog converter, because the MBED is then taking that signal and giving out an analog signal to the LED. Okay, the 12 bits, the 10 bits, we'll look at them in later videos. And then all we're doing is, look, we're storing it. We're looking at a little bit of data types here. We're storing a float value because it's got a decimal point in it. It's not an integer, which is just a whole number, because we've seen it could be taken in basically decimal points. And then what we're doing is we're just reading from the potentiometer. Okay, we're reading along that pin 15. We're storing it in here. And what it's just given us is it's just given us a raw value of the sensor. Okay. Now we'll talk a little bit more about what the raw value and stuff means, but just note it's a value between 0 and 1. Okay. Based on this conversion. Okay. So it's not a value of 3.3 volts or whatever it is, it's a value between 0 and 1. So once it reads that, it stores it in there, and then like I said, we're putting the output as a percentage value again between 0 and 1. We're just supplying that raw value into the LED. Remember, that's just a percentage. So we're saying if the value is at say 0.25, we're putting 0.25, 25% of our available power to that output pin. Okay. Then we're waiting half a second and we're looping back around and checking, is there a new value at the potentiometer, and if there is, we're going to output a value accordingly. Okay. So it's a bit of an introduction to analog control. We're going to do some more on it. We're going to look at other videos which will help. But just note, at this stage, you have a couple of different analog inputs. You have only one analog output pin. Your sensor, your analog input, is taking in a value, it's reading in a value on that pin, and it's a value between 0 and 1 based on this conversion. Okay, a bit of maths in behind that. And then it's giving out a value onto that pin. Okay, again a percentage value, which would be based on this conversion and how much output current or voltage it's going to give. And then it loops back around.